Okay, for geometry, we've got 4.7 coordinate geometry of triangles. So the first thing we're going to do is we're going to use coordinate geometry. Okay, so this is the coordinate grid, okay, to identify characteristics of triangles. So we're taking what we've got and we're going to use it on the coordinate grid as well, what we know. The second one, prove and apply the triangle midsegment theorem. We are not actually going to do today. And then the last one is use coordinate geometry to prove, okay, we're going to be proving triangles congruent again. So sometimes the only way to find out is if we can prove those things and use the coordinate grid. So coordinate geometry uses coordinates. Okay, we're using the coordinate grid, usually related to the Cartesian plane or the coordinate grid, to examine and describe geometric relationships. So, like some things that we might do, the fact that the slopes of perpendicular lines are negative reciprocals of each other. Okay, this is something that we learned in Algebra 1. Okay, is that the slopes of perpendicular lines are negative reciprocals of each other, can be used to determine whether a triangle is a right triangle. Okay, because if they have perpendicular lines intersect, okay, when perpendicular lines intersect, they make a right angle, and then you might have a right triangle in there. The distance formula can be used to determine whether a triangle is scalene, isosceles, or equilateral. So the distance formula can tell us what kind of triangle we have. Okay, so there's lots of things that we're going to be able to learn and use. In example 1 then, let's dive right in. There's going to be a lot of work to these. So we've got the algebra of the formula, the geometry tied in there. So example 1, find the slope and length of each side of the triangle. So we're finding the slope, which is m, right? And the length of each side of the triangle. Well, that's going to be, the length is going to be the distance, okay? Because it's going to be the distance of like A to C or A to B. Then we're going to classify the triangle as specifically as possible. All right, so here's the thing. We've got 3 sides to this triangle. Okay, so I'm going to break up my paper because we have side A, C, right, or side A to B here. All right, so I'm going to do all my stuff for AB here. I'm just going to go ahead and make a table kind of. All right, I'm going to do all my stuff for AB in this first column here, okay? Because we are finding the slope and the length of it. And so then I'm going to do all my stuff for here. So let's do the slope first of AB. Slope is our y2 minus our y1 value over the x2 minus the x1 value. So if we're talking about A and B, we can have our y values, 1 minus -5 over our x's. So if I did 1 minus -5, I need to do -7 minus 1. So 1 minus -5, that's the same thing as plus a positive. So that's 6. -7 minus 1 is -8. And that could simplify to be -3/4. Okay, but there's our slope for AB. Now I need to find the length of this side, right, from A to B. So I'm going to use the distance formula. So I'm going to have the distance equals the square root, I'm going to have to work hard to get it all in there, of the difference of my x's. Okay, so my x is -7 and 1. So -7 minus 1 squared plus the difference of my y values. So if I started with A over here, I had -7. I'm going to have to start with 1. So 1 minus -5. So again, this is the same thing as plus a positive. I'm going to go ahead and put that in there. Okay, so this is going to equal the square root of -7 minus 1 is -8 squared plus 1 plus 5 is 6 squared. You might notice that those are the same numbers as we got up here, just in a different order. I'm going to afraid I'm going to run out of a little bit of room here. So I'm going to say equals, because this timer's in my way, the square root of negative 8 squared is 64, plus 6 squared is 36. All right, so that's equal to the square root of 100, which is equal to 10. All right, so this distance is 10. All right, next up, I'm going to do B, C stuff. Okay, so BC here. So first we need to find the slope. Okay, so now I'm looking at B and C. So my slope is my y's, so 3 minus negative 5 over my x values, 7 minus 1. So 3 minus negative, that's the same thing as plus a positive. 3 plus 5 is 8. 7 minus 1 is 6. So this is equivalent to 4/3. The slope there is 4/3. All right, now I need the distance. So what's my length from B to C? What's this distance or that length? Okay, so I have to use the distance formula. D is going to equal the square root of my x values, so x2 minus x1, 7 minus 1 squared plus my y2 minus y1, so 3 minus negative 5 squared. Again, this is like plus. So this is equal to the square root of 7 minus 1 is 6 squared, plus 3 plus 5 is 8 squared. I keep making that much longer than I need. So that's equal to the square root. 6 squared is 36, plus 8 squared is 64. That's equal to the square root of 100, which is equal to 10. So this length is 10. Well, so far, what do you know about the sides? Well, we have two sides that are congruent, right? This side is congruent to this side. Now, they don't have the same slopes, okay? Their slopes are different, okay? You could write that on there if you wanted, but their sides are the same. So currently, we know that these are isosceles. It's an isosceles triangle. All right, let's do our next one. Our last side is side AC. Okay, so the side length here. So first up, we need to find the slope of AC. Our rise is our y values, so 1 minus 3 over our x values, negative 7 minus 7. 1 minus 3 is negative 2. Negative 7 minus 7 is negative 14. A negative divided by a negative is a positive. Okay, and this can be reduced to 1/7. So the slope there is 1/7. Nope, not parallel. Okay, either. Let's find the distance. So the length from A to C. What is that distance or that length? D equals the square root of x2 minus x1. So negative 7 minus 7 squared plus y2 minus y1. 1 minus 3 squared. So this equals the square root. Negative 7 minus 7 is negative 14 squared, plus 1 minus 3 is negative 2 squared. All right, so this is going to be equal to the square root of 14. Negative 14 squared is negative 14 plus negative 14, which is 196. Sorry, my marker doesn't want to work. So 196 plus negative 2 squared is 4. So this is equal to the square root of 200. There is not a beautiful square root for 200. So you could give me the decimal. I would take that. It's approximately 14.14. Or you could tell me the exact answer is 10 times the square root of 2. We haven't really gone over that yet. We did it in algebra, but we haven't reviewed it much here. But the length here is 10 times the square root of 2. So not equilateral. Okay. But we do have a scalene triangle because we have two sides that are congruent. So we do know that it's scalene. All right. What about these slopes? Do we know anything? How do they help us? Right. We have a slope of -3/4 and a slope of +4/3 and then a slope of 1/7. Well, we know parallel lines, right? To be parallel, they have to have the same slope. Well, none of them have the same slope, so we don't have any parallel lines. To have perpendicular lines, we need opposite reciprocals. Do we have any opposite reciprocals? Yeah, -3/4 and positive, so this one's negative, this one's positive, so that's opposite. And they're reciprocals. 3/4 is a reciprocal of 4/3. So AB is perpendicular. So AB is perpendicular to side BC. That's huge because that makes, if these two, AB and BC, are perpendicular, that means there's a right angle in there. So this is a right scalene triangle. Okay, so we had to do all that work to find out that we have a right scalene triangle. Oh, not scalene. I said scalene. Why do I keep saying scalene? Scalene means none of the sides are the same. Goodness gracious. A right isosceles. I hope that you were yelling at me as I kept saying that over and over and over again. A right isosceles triangle there. All right, so lots of work for one problem. And that's even without the proof. Okay, next up. In any right triangle, the Pythagorean theorem can also be used, right? The Pythagorean theorem, hopefully you remember this, to find the length of the hypotenuse. Okay, it's only good in a right triangle to find the length of the hypotenuse. Okay, so the Pythagorean theorem, do you remember what that is? Okay, it's a squared, good, plus b squared equals c squared. A is a leg, b is a leg, c, however, is the hypotenuse. Always. It always, always, always has to be the hypotenuse. So could you use it in example 1? You totally could have. After we had found the length of AB and BC and the slopes and realized that they were, if we had looked at the slopes sooner and realized it was a right triangle, we could have used the Pythagorean theorem to find the length of AC. Totally could have done that. All right. Coordinate geometry is especially helpful for examining the mid-segments of a triangle. Okay, a mid-segment is right here. Okay, is what we're going to be looking at. So the mid-segment of a triangle is the segment connecting the midpoints of two of the triangle sides. So notice, right, we're saying this section, so B to C, is congruent to D to A. That's why these both have that mark. Okay, well that makes D a midpoint here. Then we have a similar thing going on over here, right? We have two hash marks here that says, okay, well from E to C is congruent, because it has two marks, to E to A. Well, if that's the case, this point here at E is a midpoint. So what we have, this D to E is a mid-segment. So a mid-segment. because it connects the midpoints of two of the triangle sides. So it connects the midpoint D to the midpoint E with a mid-segment. That's what a mid-segment is. All right, a mid-segment of a triangle is parallel to the third side of the triangle and is half the length of the third side. So in this triangle over here, right, we connected this side to this side. So the bottom here, BC, is our third side. So notice this is saying that this is parallel. So the mid-segment is parallel. That's what this mark here is for, right? That's a parallel mark. So those two lines are parallel. And DE is half of BC. That's what this is saying here. The length of segment DE, so from D to E, is half the length of BC. That's our triangle mid-segment theorem. So those two things are going to be super helpful for us. Okay, let's go on to the back side. In example 2, it says find the midpoints of AB and BC from example 1. So we're using the same exact shape. Okay, we're just doing more with it. So we're going to find the midpoints of AB and BC from example 1. Label them D and E respectively and draw the midsegment DE. Find the slope and the length of the midsegment and compare them to the slope and the length of the third side, AC. Whew, okay, so we got a lot going on here. So we're finding the midpoints of AB and BC. So we need the midpoint formula. Okay, I didn't give it to you. I gave you the slope earlier. I gave you the distance earlier. We need to recognize that we need the midpoint formula. Okay, remember the midpoint formula was that capital M. Okay, and that's when it's in parentheses. When we take our x1 and our x2 values and divide them in half, we're finding the average of those two. And then our y value is going to be our y1 plus our y2, and divide those in half to find the middle or the average of those 2 points for our midpoint. Okay, so there's our formula. So let's do it for AB. All right, so AB, we've got -7, 1, and 1, -5. Okay, so the midpoint, let me make it a capital M, the midpoint of AB. We're taking our x values. Those are the first ones. So -7 plus 1 divided by 2, comma. Now we need the y values. So 1 plus -5 divided by 2. All right, so this is going to equal -7 plus 1 is -6 divided by 2, comma. 1 plus -5 is going to be -4 divided by 2. -6 divided by 2 is -3. -4 divided by 2 is -2. So the midpoint of segment AB is -3, -2. So let's see here. We're going to graph that. So we're going to go -1, -2, -3, -1, -2 right here. And we're supposed to label those D and E respectively. So AB is going to be D. There is our midpoint D. Okay. All right, next up, we need the midpoint of BC. So now we're looking at B and C. All right, so we're adding our x values here. So 1 plus 7 divided by 2. That'll give me my new x coordinate. And adding our y values. So we did 1 plus 7. So we're going to do -5 plus 3 divided by 2. That's going to give us our new y value. 1 plus 7 is 8 divided by 2. -5 plus 3 is -2 divided by 2. 8 divided by 2 is 4. Negative 2 divided by 2 is negative 1. So my midpoint of BC is 4, negative 1. So again, let's graph that. 1, 2, 3, 4, negative 1. It's right on the line. And this is supposed to be E. Isn't it magical how it works out? Like we do the formula and we can check it. It should be right on the line. Okay, so then we're supposed to draw mid-segment DE. So we just draw this across here. Ta-da! I'm actually going to go ahead and label this. E was 4, negative 1. And D was negative 3, negative 2. And that's a comma. Okay, so it'll be helpful. Because then it says, find the slope and the length of the mid-segment. So that's DE. Okay, so we got more work to do. All right, so now we're looking at DE. Let me grab a different color here. Okay, so the slope of DE. Notice this is a lowercase m. See how it's got like curves? This is a capital M. It's got peaks like mountains for midpoint and slope. Same letter, capital and lowercase. It matters. All right, so for our slope is the change in our y values. So negative 2 minus negative 1 divided by, that's our rise, over our run. Negative 3 minus 4. So negative 2 minus negative 1, that's the same thing as plus. So negative 2 plus 1 is negative 1. Negative 3 minus 4 is negative 7. Well, that reduces to be a positive 1/7 because a negative divided by a negative is a positive. So the slope of DE is 1/7. The distance, so distance of DE equals the square root, the difference of our x values. So negative 3 minus 4 squared plus the difference of our y values. Negative 2 minus negative 1 squared. So this equals the square root of negative 7 squared plus negative 2 minus negative 1, again, is the same thing as plus. So negative 1 squared. So that's the square root of negative 7 squared is 49 plus negative 1 squared is 1. So that equals the square root of 50. Okay. Oh, wait, hold on. Just a second. Oh. Yeah, that's right. Sorry, I was looking at the book and I did a different example than the book did. Because I did A, B. No, I did A, B, and BC. Oh, the book did AC and BC. There we go. That's why. Because you can have mid-segments in different places. But I was like, why is this not working out from what we did in the book? That doesn't make sense. But it does. It does. All right. So then we've got the there we go. Okay, sorry, I just had to double check. All right, so if we are then going to compare these, okay, we're comparing them to the slope and length of the third side, AC. Well, when we did this earlier in example 1, we got that AC, the slope of AC, was 1/7. Well, now our slope of DE was also 1/7. Okay, so what's that tell you? Good. It tells you that they're parallel. They have the same slope. So it tells you that they're parallel. Excellent. All right. Now, how about the length? The length of side AC earlier, or the distance, was the square root of 200. Okay, and we got here, our distance is the square root of 50. Okay, but we were told, like the theorem says, that this is half of this length. So let's see if that's true. What is the square root of 200 divided by 2? Give me the decimal for it. Okay, it's 7.07. What's the square root of 50 equal? 7.07. So yeah, even though they don't look like half because we're using a radical, doesn't mean they aren't. You have to engage your brain to go a little further and solve. Okay? All right. So now on to example 3. Again, we're using the same shape. Okay, so we're going to use the results of example 1 and the midsegment theorem to find the slope and length of the other 2 midsegments of triangle ABC. Yikes! Okay, so we get to do this again. Okay, because we just solved that one and we had midsegment in here, I should have kept it, here was what we called D, right? And then we had 1, 2, 3, 4, -1 was E. Okay, so we had this midsegment in there. So now we want to find the other 2 midsegments. Okay, so we can do this. All right. It just means that we need the midpoint. We only need one more midpoint actually, right? Because we found midpoint D and we found midpoint E. So now we need midpoint F. We need the midpoint on this side. And once we have it, we can make all 3 sides. So we just need one more midpoint. All right, so midpoint of AC. Okay, so we have, it's our x coordinate. So we're going to have -7 plus 7 divided by 2. And then our y's, 1 plus 3 divided by 2. So -7 plus 7 is 0 divided by 2, comma, 1 plus 3 is 4 divided by 2. So our midsegment, or midpoint, sorry, of AC is going to equal 0 divided by 2 is 0, 4 divided by 2 is 2. So 0, 2. 0, I'm not going left or right, 0 up to right here. And that's F. So now, if I connect those, I have an inverted triangle, right? It's inverted from this one. The point was down at the bottom on the original, and now the point is up here at the top for the second one. All right, so now we need to find the slope and the length of the other 2 midsegments. So this wasn't even really part of it. We needed to do it, but it ain't part of what we actually have to do. So we're going to find the slope of DF. All right, so let's see. F here is, we said 0, 2. And this one, E was 4, -1. And F is, I don't even see that point. 1, 2, 3, -3, -2. Okay. All right. So the slope of DF is equal to our change in our y's, right? The rise. So we're going DF. DF. So 2 minus 2. Sorry, 2 minus -2 over. So I did 2 minus -2. 0 minus -3. All right, 2 minus -2, that's the same thing as plus a positive. So 4, 0 minus negative, plus a positive. So 4/3 here. So M equals 4/3. And the length, okay, so distance of DF is the square root of the difference of our x's, so 0 minus negative 3 squared, plus the difference of our y's, 2 minus negative 2 squared, which equals the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25. So the distance of DF equals 5. And remember, if you remember, the length, so let's see, this is 5. And the length of this side was 10. So 5 is half of 10. Don't you like how that works out? And these two are parallel. That's what the midsegment theorem said. Just like this one, DE is parallel to AC. All right, now we get to do the same thing for EF. So the slope of EF. All right, so slope is your change in y values. So negative 1 minus 2. So I went negative 1 minus 2 over 4 minus 0. Negative 1 minus 2 is negative 3. 4 minus 0 is 4. Negative 3/4 is this slope right here, which is the same slope as this line, which means they are parallel. Okay, that's what the triangle heads are. And I need to find the distance. So the distance of EF is the square root. Oh, I wrote that way too long of a line. Okay, the square root of the difference. It's our x 1 minus x2, or x2 minus x1. So 4 minus 0 squared plus the difference of our y's, negative 1 minus 2 squared. So this equals 4 minus 0 squared is 4 squared. Negative 1 minus 2 is negative 3 squared. So this equals the square root of 16 plus 9, which equals the square root of 25, which equals 5. Hey, here this side is 5. And before, this side over here was how long? 10. So this is half. The midsegment is half of the length, just like the theorem said. Okay, just like the theorem said.